what are these bitmap indexes that I'm creating? Well, the bits represent the individual values of the column. There's a bit for each, a bit map, one should say, for each distinct value. Important point, including nulls. B-tree indexes cannot include nulls, part of the ISO standard. Null isn't equal to anything, not even another null. It isn't not equal to anything either, not even another null. So it becomes logically impossible to put a null into a B-tree index because B-tree indexes rely on using equalities to compare values. So nulls can't go into B-tree indexes. They can go into bitmaps. Bitmap indexes are an Oracle proprietary structure. Oracle can include nulls. And you saw the null being used in one of the demonstrations I did earlier. The null predicate was indexable. The space usage is very efficient, as demonstrated. But the beauty of it is the Boolean algebra, the performance. The row sets I've got in the demonstration schemas are really a bit too small to demonstrate performance. But you can see just from looking at the cost calculations that the optimizer is thinking that the bitmap index is going to be better. So the Boolean algebra across multiple columns can be phenomenally efficient. That means any predicate where you've got columns connected with and, or, not, where so-and-so is equal to this, or this, and not something else. Multiple columns connected into Boolean algebra with these expressions. Bitmap indexes, many indexes can be used at once, whereas with B-tree, Oracle has to choose one, retrieve the rows, and then filter to apply the rest of the predicates. It's done through bitmap merging, the bitmap merge operation. This will occur in your session's PGA memory. And there are some memory condition issues there, which may be important at some sites. DML, by the way, is a problem. DML is an issue. Why don't you use bitmaps everywhere? Well, there are cases where B-trees will perform much better, of course, but there can also be a locking issue with DML, right, which I'll demonstrate at the end when we come to usage cases. I should mention, by the way, spelling mistake included, they are an Enterprise Edition feature. So you don't pay extra for them, but you don't have bitmaps in Standard Edition. There is a workaround, which we can maybe demonstrate if we have time, to get the equivalent functionality in Standard Edition that we can get set up. So that's the theory. This is what they look like. Go back to my table, emp, select star from emp. Right, select star from emp, and what have we got here? Well, if I create a bitmap index on job, create a bitmap index on job, and syntax, just that. Right, just use the keyword bitmap. What Oracle will do for the job bitmap index is look at the distinct values, which are clerk, salesman, manager, president, analyst. Each distinct value gets its bitmap. The first row in the table, Smith, is a clerk. So you put a 1 on the clerk bitmap and zeros on the other bitmaps. Second employee, Alan, is a salesman. So we put a 1 on the salesman bitmap for the second row, zeros elsewhere. Jones Ward is also a salesman. So we put a 1 there, zeros there. The fourth row, Jones, is a manager. So the manager bitmap gets a 1 for the fourth row, zeros elsewhere. That's how we build these things up. Similarly for Deptno, the department number bitmap index. The first employee, the first row, department 20. Therefore, 0, 1, 0. Second employee, or the second row, I should say, department 30. Therefore, 0, 0, 1, and so on. Then we come to the clever bit, how we can use these things. So set, auto trace on, explain, and run my little query. Right. We've retrieved the line of bits for manager. And that line of bits 0, 0, 0, 1, 0, 1, 1, 0. Then we retrieve the line of bits for Deptno equals 30, which is 0, 1, 1, 0, 1, 1, and so on. Or 30, 20. I'll get there eventually. 20. And the line of bits for department number equals 20 is 10011, 10011, and so on. I've connected in my query, I've connected the two filters with AND. Boolean algebra. Takes you back to college, doesn't it? Boolean algebra, we AND the two rows together. 0 plus 1 equals 0. 0 plus 0, 0. 0 plus 0, 0. 1 plus 1, 1. 0, 0, 0, 0, and so on. And it drops straight out. The only row that satisfies both those criteria is the fourth row. This is lightning fast. This is lightning fast. It's really, really efficient, even in hardware terms. This sort of thing can be done in registers on the CPU. It shouldn't involve any programmatic input at all. It's really fast.
So much faster than comparing values from, well, just comparing values, which actually Oracle cannot do in merging multiple indexes on the same table.
That's exactly it. It's not only efficient because we're just comparing bits and doing algebra between them. Think of things like space. You know, it's bits. It's not whole bytes and representations of columns. And the complexity, if the query had more and this or this and not something else, you would see all those operations coming through. And what at college we used to call the truth table, we'll be doing appropriate arithmetic, Boolean algebra, Boolean arithmetic between all the rows to come up with results. It's lightning fast. That's the basic use of bitmaps.